Welcome to Pre-Calculus. Today we will investigate expanding and condensing logarithmic expressions. We'll take a look at four examples, two that are expansions and two that are condensations. So our first example is log base 6 of the argument x, y squared. And we need some rules or properties of logarithms in order to unpack this logarithm and expand it. So the first rule that we need is called the product of a logarithm. And the way that it goes is if I have a logarithm base b of an argument that's something multiplied together, in this case x times y, I can expand that as a sum. So the product would transform into a sum of log base b of x plus log base b of y. And that is one of the things that we need here to expand our statement. The other thing that we need is the logarithm property of powers. And the way that that rule goes is if I have a logarithm base b of some argument x to the power of r, that power, when I apply the logarithm, will come out front as a coefficient. This is equivalent to the power r as a coefficient times log base b of simply x. So those are the two rules that I need to expand this example. So let's take it in two steps. I'm going to first of all apply the product of a logarithm property. So this logarithm base 6 of xy squared is equivalent to logarithm base 6 of x plus logarithm base 6 of y squared. So in that step, I'm just converting the product into a sum. And then to finalize the expansion, what I need to do is make sure that I take any powers that are on the arguments, either the x or the y squared. So I do see it, it's there on the y. And I want to apply this second rule, the property of a logarithm power. And the way that that's going to look is as so. The first term won't change, log base 6 of x, but the second term will become plus the old power 2 on the y as a coefficient, so 2 times log base 6 of y. And that I'm going to box because that is fully expanded. Let's take a look at a second example. So our first example was about a product. We converted it to a sum. Our second logarithm example is a quotient. I've got division, and so I need another rule. And the rule I want to pick up, it's similar to what we saw with the property of a logarithm product, but this would apply if I've got some division. So log base b of x over y, I can expand that kind of statement as a difference, log base b of x minus log base b of y. I'm going to need the power of a logarithm rule again. So log base b of x to the power of r. Same rules we wrote. Previous example is r is a coefficient times log base b of simply argument x. So again, you gather your rules, and now I want to apply them to expand this specific logarithm. So my first step would be to split the division into a difference. I want subtraction instead of division. So log base, I don't have a base written, so I could either leave it suppressed, or I could put the base at 10. Anytime you have a log that's not got a base written, it's base 10. So I like to write it, log base 10 of u to the power of 4. Instead of division, I'm going to transform that to subtraction, log base 10 of the denominator v. Again, to finalize the expansion, I do want to take this power of 4 and let it become a coefficient. So my final version here in the expansion is going to be 4 times log base 10 of u minus log base 10 of v. And that completes that expansion. Let's also take a look at two examples that involve condensing an expression. So it's really the reverse task. Instead of one logarithm that I want to spread out, unfold, I've got an unfolded, spread out logarithm that I want to bring together as one logarithm. So it really has to do with just reversing our rules. So as I look here, I've got a subtraction, and the way I'm going to transform that is back to a division. So this logarithm, the way that I would start condensing it is to use that property that we saw in our last example, log base b of x over y equals log base b of x minus log base b of y. So what we've got is now the left or the right hand side. We want to go back to the left side. So I can do that pretty easily. This is going to be log base 8. By the way, these have to be the same bases to apply this property of u over, so I got to do something first. This 4 on the second expression, I'm going to replace using my property of a logarithm power. So remember, log base b of x to the power of r equals r times log base b of x. So again, I've got this version on the right. I want to take it back to the left side. So that's going to be v to the power of 4. And that is a single logarithm in that instance. We'll take a look at one final example where we are, again, condensing an expression to a single logarithm. So here I've got log base 6 of 8 plus 2 times log base 6 of 5. So the way this one presents itself, it's got an addition, it's a sum. And so the rule that I want to apply is this one, the log base b of xy equals log base b of x plus log base b of y. And again, what we're seeing is we have the right-hand side. We want to take it back to the left. But I see, again, I've got to apply my power of a logarithm property. Log base b of x to the power of r equals r times log base b of x. So I'll not skip this step for this one. We're not going to change that first expression at all yet, log base 6 of 8. But what I want to do is I want to replace this 2 as a power. So I'm going to write this as log base 6 of 5 to the power of 2. And so that's applying this second property. Let's apply the first property to get one single logarithm. So this is equivalent to log base 6 of 8 times 5 squared. And notice, even if I've got just numbers, as in this example, the same properties will apply to either expand or condense a logarithmic expression. Thank you for joining for this investigation of condensing or expanding logarithmic expressions. See you soon.